According to the State Department of Finance, California's population was 33.218 million at the beginning of 1998, 33.765 million at the beginning of 1999, and 34.336 million at the beginning of 2000. A. Calculate the percent increase from 1998 to 1999 and the percent increase from 1999 to 2000. Does this suggest exponential growth? So the first thing we need to do is calculate the percent increase from 1998 to 1999. And the way you do that is first you need the difference in the populations. So the population in 1999 minus the population in 1998, which was 33.765 minus 33.218. That ends up being 0.547 million. That is the difference. That is the amount of people that have been added to the population in that year. Then you need to take that amount and you need to divide it by the original amount. So the difference in the amounts divided by the original amount, and that gives you 0.01647, which ends up being convert that to percentages, 1.647% increase in population from 1998 to 1999. Then we're going to do the same thing from 1999 to 2000. We need the difference in the populations for our numerator, and then the original population in the denominator, and you end up with 1.691% increase. Now, does this suggest exponential growth? Well, 1.647 and 1.691 are pretty similar, so yes, I would say that because the percentages are the same, that this is exponential population growth. Okay, part B, assuming exponential population growth, write the equation to model this data. So an exponential function is y equals a times b to the x, where a is your initial value, b is your growth rate, and then x is going to be time. In this case, it's the number of years after the initial year. If I'm talking about the year 2020, for example, I would not plug in 2020. I would plug in the number of years after my initial year that I used to find the a value. So in this case, I'm going to choose to use 33.218 as my initial value for 1998. And then my percent increase from 1998 was 0.01647. So my growth rate is 101.647%. That's why my base is 1 plus, because I have 100% of what I started out with, and I'm adding an additional 1.647%. And then X will be the number of years after 1998. So this is the function I used. The model that the book uses is different, and the model that you choose to use might also be different. There's no right answer for this one because you could have used 1998 or 1999 or 2000 to represent your initial year. Use your model to predict California's population in 2020. So in my case, I start out with this, which is going to be the number of years after 1998 as my X. So from 1998 to 2020, that's a value of 22 years. So I plugged this into my calculator, and I got 47.583 million people. Part D. The increase in population is proportional to the current population. In other words, if the population is growing 3% each year and the current population is 1,000, the increase is 30 people. If the current population is 5,000 people, the increase is 150 people. According to your model, approximately how many people did California's population increase in the year 2000? So we just want to know what is the increase in the number of people. According to my model, which is not the same model that you might have used or the book used. So what I need to do is I need to figure out what was the population in 2001 and subtract it from the population in 2000 using my model. So 3 years after 1998 is 2001, and 2 years after 1998 is 2000. So I plugged in 3 and 2 into my model, and I subtracted, and I got 0.565 million people. Part E, explain why the increase in population is proportional to the current population. What is the constant of proportionality? Well, this is proportional because when you take your current population and you multiply it by 0.1647 in my case, when you take your current population and you multiply it by that rate, you end up with the next population or the increase in population. So that's the amount that you are adding to your current population. So in like the previous example, I was adding 0.565 million people to my current population. And that I found by subtracting the populations using my exponential model. But you could have also just taken the population in 2000 and multiplied it by 0.1647 and got the increase in the population by doing it that way. So yes, it is proportional. The constant of proportionality for the increase is just 0.01647 in my case.